Someone on YouTube actually asked if it was possible using a pixel processor node to build a Kuwahara filter within Substance Designer.
Challenge accepted.
I had to Google that to see what a Kuwahara filter was, but it seems to be a filter that kind of gives a bit of a paint daub effect to a particular texture. And I was able to find a few examples of code that was done using, I'm not sure which language, I think it was Python. And just by deconstructing and really reading the code line by line, I was able to replicate the Kuwahara filter within Substance Designer. So this is my input picture, and this is the result of using a Kuwahara filter with a sample size of 10 by 10. So you can see the kind of effect that it gives. We start from this particular picture here of Lisbon, and once you run the Kuwahara filter on top of it, then all of those details, most of them just simply disappear, and all you're left with is those more solid colors, perhaps, that really gives a very painterly effect to the texture there. So here's what it looks like within the Kuwahara filter package itself. I have what are 4 pixel processors whose job it is to calculate different values and different results for 4 different quadrants around each pixel that is sampled. Within each pixel processor, the code is really broken down into 3 different sections, if you will. The first section is a section where I simply set a few variables that are necessary. And then after that, I have a section of code that is pretty much essentially just one function that runs over 100 times. And what it does is that for each pixel, it calculates a grid of 10 by 10 pixels around it, takes the average color of that and other measurements such as standard deviation and stuff like that. So these are all values that are necessary to properly calculate the result of the Kuwahara filter. And then finally, I have a third section of code here, which is essentially just 3 lines of code whose job it is to calculate both the mean color for each of those 10 by 10 grid of pixels we've just mentioned before, and what is the standard deviation, or rather, what is the average standard deviation of each pixel's color from that particular mean. Anyway, so once that has run what is essentially 4 times for each pixel, then afterward, I have one last pixel processor whose job it is to select what will be the final color for each pixel that is output out of the Kuwahara filter. And so the result of all that, as we said, is that you start with this realistic picture that is here. And once you run the Kuwahara filter on top of it, you end up with this kind of very stylized picture that has this very paint dobby effect to it. So if you really want to master Substance Designer, it's really good to learn how the pixel processor works, because as you can see, you can do a lot of really cool stuff with it. And so what I want to do with you today is to really just explain to you in a very fundamental way how the pixel processor works. And I want to tell you everything about the $position variable, which is arguably the most important variable you could ever manipulate within a pixel processor. And I also want to tell you that if you truly want to master Substance Designer, that I have posted so far up to 5 hours of content on all the fundamentals of the software that you need to know to be able to pick it up and start creating your first graphs. And I have posted all of that on my own platform at https://outgang.studio. In the next few weeks, I will also be uploading more advanced content, such as a very detailed step-by-step breakdown of how I have gone about to create this particular Kuwahara filter. And I will even be distributing the resulting graph of that to all members. So go and check it out at https://outgang.studio for even more educational content on Substance Designer. So let's talk about the fundamentals of the pixel processor node. So just to compare the value processor with the pixel processor to really understand what their differences are, what the value processor does is that it runs whatever is within its function graph. It's going to run it once and output the value, the result of whatever kind of computation are within its graph there. It's going to output that once. Whereas what the pixel processor does is that it's going to run whatever is within its function graph. It's going to run that for every pixel that you have within your texture. And so that's actually very useful because we can actually modulate the result of the pixel processor by using the position of each pixel within the pixel processor as a variable. So let's use this polygon here as an example, and I'm plugging it within my pixel processor. So what I essentially need then, one is that I need to access that variable for each individual pixel. I need a way to get access to that variable that defines for each pixel what is its position. And second of all, I need a way to sample the incoming texture that I have plugged in there. So I'm going to go ahead here within the pixel processor. I'm going to press Control E. And so in here, we really need then two things. So as we said, one is that we need to access that variable that gives for every pixel its position. And second of all, we'll need to be able to somehow sample the input texture that we have. So if you think of the position variable then, right, the coordinate over a texture really goes from 0 to 1 in both the x-axis and 0 to 1 on the y-axis, right? So 0 to 1, and on that particular coordinate grid that we have just defined, every pixel represents a decimal point from 0 to 1 on both the x and the y. So that means that we need a float2 vector to really represent a position variable properly, right? And so it just so happens that we have access to that if we go within our function graph here of our pixel processor, and I select a getFloat2 node. It just so happens that within the drop-down menu within the pixel processor, we actually have access to the $pause variable that you can see. So this is already there. We don't have to create it. We don't have to do anything at all. We just have to create a getFloat2 node within our pixel processor to be able to access that. The $, by the way, just means that it's one of the default variables that you can access within Substance Designer. You can see a full list of those variables online. It's very easy to find. We can't take this variable, unfortunately, and set it as the output. You can see if I right-click on it, I can't actually set it as the output from the pixel processor, because as opposed to the value processor, which can output either float1, float2, float3, float4, it can output anything you want in terms of a variable. A pixel processor node can only output either a float1 or a float4. So if we wanted to, let's say, visualize what the pause variable actually looks like, what we would have to do then is to vectorize it. So combine it with another float2 value of some kind to create a float4 that can afterward be output. So let's go ahead and do that. Let's create another float2. And in this case here, so this will represent the, in terms of a color, this will represent the blue color and the alpha. So let's set the bottom component here to 1, because that will be the alpha. And the top, let's leave it at 0, which will be the blue color in this case. And then afterward, let's add a vector float4 and combine our two float2s into our float4. Set this as the output. And now, if we look at the result of our pixel processor, if we look at its output, you can see that what we have is essentially the position of each pixel that is represented as a color that goes from black all the way to yellow, or essentially goes from 0. We take a look here at the R and the G values here within our information little tab at the bottom there. The idea goes from 0, 0 in the top left corner of the texture to 1, 1 at the bottom right of the texture. You can visually clearly see here what is the representation of the pause, or the $ pause variable within the pixel processor. And then secondly, the other thing that we were talking about is how to sample a particular texture that is input within the pixel processor. What we need is to hook up to that pause variable a sample node. And in this case here, this is a gray input, as you can see here. And let me also just go here and set my pixel processor as a grayscale pixel processor. And so what we need is to hook up to our position variable a sample gray node. And here you can see that its input, it takes a position input. And so we will go here and connect the output of our getFloat2 $, pause node to the position input of our sample gray node. And as I set this here as the output of the pixel processor, now we have the pixel processor acting as a pass-through node. Now, it's important to say that although I have only one input image right now within my pixel processor, there's actually no limit to the amount of inputs that you could have within a pixel processor, okay? You can see that if I hook up this here to the input image 1, I have a connector that appears for input image 2, so on and so forth. There is no limit to the amount of connectors that you can have within a pixel processor, at least none that I have found. I believe that the furthest I've gone is connected to over 100 inputs so far. So if there is a limit, I haven't found it yet. Okay, so what happens if I actually modify this particular variable that is here then, right? If I actually start to play around with that, what's going to happen to it? Since this says, okay, take your own position. For each pixel, take your own position and go sample the same position, essentially on the input image 0 in this case here. So we can start to create some kind of funky stuff with this, right? Let's say that I go in here and I plug in a multiplication node between my float2 node here and my sample gray node there. You can see that the moment that I have put in this multiplication node between those two nodes, now the output of my pixel processor has completely disappeared because now it's actually multiplying the position of each pixel by a value of 0 since our B connector is right now completely empty. It's using the value 0 instead. So let's go ahead here and plug in a float2 node instead to that. And once again, same thing here. We're multiplying the position of each pixel by 0. So we're still getting the input here that is black. But if our pixel at 0, 0 was a different color, that's the output we would be getting right now. And so if I set these values back to 1, now we're back at where we started. But you can see that things start to get a little bit funky if I start to have decimals in there, right? You can see that as I multiply, or in this case, as I multiply by decimal value, I'm actually transforming the input texture. I'm actually transforming it. So in this case, I'm actually scaling it. Because what I'm saying is, take your own position. Let's say that I set this value to 0.5 and 0.5, right? What I'm saying is for each pixel within the pixel processor, what I'm saying is take your position multiplied by half and then sample that particular position within the incoming input 0 texture there, which in a way has the effect of giving us the impression of zooming in over the top left quadrant of our input texture. So as opposed to think that this polygon has now doubled in size, I really would rather think about it as us having zoomed into this little quadrant that is there. I think it's more representative of what is actually happening in this particular case.
The enhancement only increased the pixelation on all these. You can't even see there's a side view mirror.
Well, it's not like on 24, Castle. In the real world, zoom and enhance can only get us so far.
Okay, so here's a basic creation example that you can do using the pixel processor. Let's say that you want to draw a circle within your image, and you want to draw it so that it has a center at a particular coordinate. So just like every pixel processor graphs, really, we have to start with a pause variable. That's really just a starting point of like everything. And then we'll need a second variable, okay? That will be the variable that will define the center of that particular circle that we want to draw in here. Let's use a float2 node, okay? And let's say that, well, for the sake of simplicity, let's go for 0.5 and then 0.5 for now. Okay, so the way that we use a pixel processor is to really, we have to think in a mathematical way. How is it that I can define in a mathematical way the kind of result that I'm looking to get?
Do you always look at it and code it?
Well, you have to.
I don't even see the code.
So I want to draw a circle within my pixel processor around the point 0.5, 0.5 with a radius that we have yet to define. But in the context of every position, how can we actually do that, right? So the solution really isn't all that complicated. What we have to do is to figure out for each pixel of our pixel processor, what is its distance to the center of the circle that we are defining. If its distance to the center is smaller than the radius that we will specify, then that pixel should be white. If its distance is greater than the radius of the circle, then its color should be black. We actually have access to a function that we can already use within our pixel processor function graph that is called distance. And what this actually does is that it essentially figures out what is the distance between 2 points. In this case, the position variable and the center of our circle. So if I go ahead here and plug in our pause variable within our distance float 2 node here, and also connect the center of our circle in there and set this as the output, you can see the kind of effect that it's actually giving me. So of course, pixels that are very close to 0.5, 0.5 will turn out black because their distance is very short. And pixels that are at the extremities will right now have a value of 0.7 or so there. And if I take this float 2 here and I actually move it around, you can see the kind of effect that it does. I'm essentially moving the center of our supposed circle there. So now that we know the distance between every pixel to the center of the circle that we want to create, then what we need to do is to run a very simple conditional statement that says, if you are within a certain distance from the center, then draw yourself as white, else draw yourself as black. So let's use now a conditional statement, which in this case, let's use an if-else statement. And let's use a smaller or equal to or lower or equal to. And what we want to say is, if the distance is smaller than another float variable that we'll create here, which will represent the radius. So in this case here, let's set this to whatever radius we really want this to be. Let's say that we start with a radius of 0.2. And we plug this here as the condition for if-else statement. Then we can create 2 more float nodes, one with the value of 1, which will be our true statement, or 0 as our false statement. And we can plug the 2 of those within our if-else node. And now, as you can see, as I set my if-else statement as the output of our pixel processor, we are now drawing a circle which radius is defined by this particular value here. I can increase it, I can decrease it, as you can see. And whose center is set with this particular variable that is here. As I've alluded to earlier, I like to, as opposed to use blend nodes, I actually really like to use pixel processor nodes in a lot of cases. I find it quite fast, and I really like the sort of bare bones kind of code that it kind of gives you that's really, really down to its very essential. And so we can actually totally add together or do all sorts of blending between different inputs very easily through a pixel processor. And I suppose at this point, you probably have a pretty good intuitive sense of how that actually works, right? So if I go ahead here and create a pixel processor node, and let's say that I have multiple nodes once again. So let me add a third node here, right? And I really just want to add together these 3 different nodes. Now you probably have a pretty good idea of how that actually works. I'm going to hook these 3 nodes up to my pixel processor, make it a grayscale. And then within my pixel processor here, what I'm going to create is a pause variable. To it, I'm going to hook it up to a sample gray node. And here it's set to input 0. I'm going to duplicate it 2 times. set these to input 1, input 2. And now I'm just going to add together all of these sample gray nodes together and set the result of that as my output node. And then I have essentially added together these 3 different images through a pixel processor node. So personally, I find it quite fast, first of all, to use pixel processor to do some of these basic add operations. But if I am trying to add together a lot of different inputs for some reason, let's say there's 4, 5, 6, 10
1 million
different textures I'm trying to really add together, as opposed to just create this huge kind of chain of blends and blends and blends and blends and blends. I really love to just plug them all into one pixel processor and do the add in there using just a simple addition operator. And for me, it just makes a graph that just winds up being sometimes a lot simpler to look at. Although it's true that blend nodes, they're very descriptive by their name, so you do look at them, you do know what a blend node actually does. Don't forget that you also have access to frames and comments within Substance Designer. So what I will do sometimes is that I'll take a pixel processor, I will just simply add a frame around it. So let's add a frame, and then I'm just going to say here, let's say add. Just like that. So I know exactly what this particular pixel processor does. And it's also very, very easy to read within the graph overall. All right, so that was a breakdown of the fundamentals of the pixel processor, and especially how to manipulate its most important variable, the $pause variable. I hope this was useful for you, and don't forget to check out outgang.studio if you want to learn even more Substance Designer, because there is a lot of content there and a lot more content than what I can really post here on YouTube. So go and check it out, and until next time, everyone, take care.